本フォーラムではアンケート回答へのご協力をお願いしております。お手持ちのスマートフォン、タブレットで簡単にお答えいただけますので、皆様のご協力をお願いいたします。それでは間もなくの開演です。本日は株式会社ワークスアプリケーションズ主催カンパニーフォーラム2016にご来場いただき誠にありがとうございます。セッションに先立ちましてご来場の皆様にご案内申し上げます。本フォーラムでは事前に申請をいただいているプレス関係者以外の方の撮影・録音はお断りしております。映像、写真、音声などの記録はご遠慮いただきますようお願い申し上げます。また、携帯電話、スマートフォンはマナーモードに設定していただくか、電源をお切りいただくようお願いいたします。本フォーラムではアンケート回答へのご協力をお願いしております。お手持ちのスマートフォン、タブレットで簡単にお答えいただけますので、皆様のご協力をお願いいたします。それでは間もなくの開演です。 本日は株式会社ワークスアプリケーションズ主催カンパニーフォーラム2016にご来場いただき誠にありがとうございます。セッションに先立ちましてご来場の皆様にご案内申し上げます。本フォーラムでは事前に申請をいただいているプレス関係者以外の方の撮影・録音はお断りしております。映像、写真、音声などの記録はご遠慮いただきますようお願い申し上げます。また携帯電話、スマートフォンはマナーモードに設定していただくか電源をお切りいただくようお願いいたします。本フォーラムではアンケート回答へのご協力をお願いしております。お手持ちのスマートフォン、タブレットで簡単にお答えいただけますので皆様のご協力をお願いいたします。それでは間もなくの開演です。
人工知能、それは複雑な計算式を瞬く間に解析し人類最高の知能を持つゲームマスターたちを破り、そしていずれ人々の職業の大半を奪う人類最後にして最大の発明。間違ってはいません。しかしそれは一面的な見方に過ぎません。検索エンジン、音声認識、受注から発送まで人の手を介さない流通システム、膨大なデータ処理による医療診断に至るまで AI テクノロジーの研究と進歩の成果として生まれたさまざまなアプリケーションは我々の生活を激変させました。そして今、人工知能を搭載した革新的企業ヒューが働き方までをも変えようとしています。煩わしい入力をなくす、欲しい情報を先回りして教えてくれる、すべてのツールがつながる、よりクリエイティブで質の高いビジネスへ、人工知能の未来に応えよう。
これよりカンパニーフォーラム2000
Now we would like to start the Company Forum 2016. The opening speaker is Works Applications CEO, Mr. Masayuki Makino. Thank you. I am Makino from Works Applications. Well, ladies and gentlemen, in your daily life, at work, we all use computers, don't we? Have you ever been frustrated with a computer? I have, all the time. I'm always mad at my computer. Now, being frustrated with our computers. Why does this happen? Is the first question. We have been using computers for decades now, over and over again, and it's becoming more and more convenient. And in order to use this computer, there are various types of information that are in the computer, and we can take it out all the time. So, it is true that we need the computer in our daily lives. We cannot live without computers. For people who work in companies and corporations, we cannot work without computers. Compared to a few decades ago, of course, it's much more convenient and it has made our life easier. But at the same time, it has changed the way we work, not just for corporate workers, even for small businesses, Sohos, artists, novelists. Everybody works with a computer. Nobody can work without a computer. Now, because you have a computer, sometimes you have to do things for the computer and taking out time from your creative work to face the computer because of the things you need to do to run the computer. Now, this is often said that, well, I used to be an engineer all along. I know that there are many people from the IT industry. So let me give you a little bit of a topic that maybe only IT people will understand. But, when we make program, when we write the codes, we have the computer check the programmed codes from the source code. We generate the programming, and it's a process called compiling. And since decades ago, this compiling programming is the same as a regular language. You write something at the end, you have to put a period and to conclude a sentence. But when you throw that program to the computer, the moment I forget a period, the computer says, "You have forgotten your period, so we cannot process this." Now, the engineers, all of you in this room, if you were an engineer, don't you think, then you put that period at the end of the sentence? Wouldn't you think? The computer can do that for you. If you know that the period is missing, then you just put the period at the end of the sentence. Mr. Computer is what you would think. This is the analogy. Just because the human being made one mistake, and we're human, we make mistakes. Just because there is one error of the key that we punched, it turns into a big error. Like you were making something on a spreadsheet and you forgot to, save it, and the power went down and the whole file disappeared, and you get so frustrated, you're probably cursing at the computer at one point. I think many people experience this. Even in your daily work, I think we've all taken this for a given. But a computer, compared to the past now, understands a lot of things. It understands, it analyzes, it deals with statistics. And because of that, human beings have to input more and more information, more than ever. What is the grouping? What is the field? What type of information is this? It's like typing a POS system in the convenience store cashier. Okay, who is this customer? This is a male. How old is he? You have to punch in all of these information. And so you're not just punching in keys. You have to put in all of these information looking at the customer. And this kind of information that the person inputs helps the management do analysis in the future. And that is why people who are the operators of these IT systems have to keep on inputting information one after another, and we have to exchange these information too. In the past, we would just draw, I wouldn't say hand draft a graph, but you know what? When I was younger, we were actually drawing graphs on a piece of paper, a graph, some numbers on a paper, pass it out to some person and the other person processing it for you. But now we have all these ledgers passed out in a full deck before a meeting. So who are making these graphs and charts? Again, people. We're spending tremendous amount of time to process this information and make these graphs and charts in preparation for the meeting. So the question is, how much time are we spending to do all of this? How much time are we using in our daily life to battle with these charts and graphs and saying, oh, this should be this color is wrong a little bit, this should be a little bit over here. And I have to do an evaluation of our employees every year, and then I have to look at what they did throughout the year, and then I have to check their payroll and everything. What I do at the very end is have to put it into an Excel spreadsheet and do all these kind of analysis every single time. I can't let my employees do this work, this tedious work, so I change the column and I change the formula here. I put this cell over there, and I do all of these manipulations manually at midnight, wondering if this is really something that I should do. Do I really need to be doing this? Well, I have to. But you know what? I didn't have to do this in the past. I now have to do this. I am actually having to work for the computers because we have computers around. It's a mystery why we're working for computers so that the computers can work for us. We have back office in the company, accounting, HR, various types of operation type of work. People who do these type of back office work understand that you are facing the computer for such a long time in your daily lives. Is this really helpful to me? Am I trying to obtain information just for myself? No. Many people are not even analyzing anything. They're first of all struggling with the computer, wondering if they should be using their time for something more creative. This is the frustration that I feel, and I would imagine some of you feel as well. I want to think about new ideas, important decision-making, communicating with my employees. This is what I want to use my time for, not struggling with the computer manipulation. That's not my work. It's not my job. Why is it that a computer is so time-consuming now to handle? For example, in your daily life, you use smartphones and various other systems. Do you need to struggle with your smartphones? Not really. Not nowadays. Younger people who are very used to smartphones, when they use their smartphones, are they working on it like, an ERP system in a typical company? No. Looking at a map, do they have to struggle for a tremendous amount of time to do their settings and to finally get one map that is static or something like that? Do they have to input the place that they are on the face of the earth to get the map? They don't have to do that. If they had to do that, they wouldn't be using it. For search, do they have to find an objective? First of all, if you're doing that while you're walking, you'll face an accident. The smartphone does not require any of this tedious work, and that is because the smartphone has advanced. To be accurate, it's not the smartphone that has been advanced. It is the cloud that the smartphone is connected to, and it's the fact that the cloud is running by artificial intelligence. Now, this statement that I just made may not ring a bell, but it is true, as a matter of fact, that an artificial intelligence is used in clouds all over the place. That is why a smartphone is so convenient. Now, the AI is not an answer to everything. It doesn't solve everything. The AI doesn't think on behalf of a human being and does not do everything for us. But wouldn't you feel the same for a computer? The computer has to be more convenient. It has to help our lives. Why am I frustrated at this computer? Putting a period at the end of the sentence because the computer is asking me to do. If we are shopping online and just to get something online, do we have to punch in a tremendous amount of information? No, if you have to do that, you just may as well go to the store. It's much faster. But the online shopping is much faster, and it has been made that way because the online shopping site has been made to be so convenient so that people will feel it attractive to use. And that's why it has evolved so much, but not in ERP, not in the corporate systems yet. First of all, in order for the computer to work, you need this kind of information to put into the database. In order to make the customer service be established, this is the kind of information that you need to input into the system. You're obliged to put information in the computer. You have to. It's mandatory. And it's because the ERP systems in corporations and enterprises have not used artificial intelligence. Now, Hugh from Works Applications is going to introduce this AI into Hugh. We have been working on it so that we can get rid of this ridiculous work that we are doing with computers today. AI is going to solve the problem for us. Now, going forward, we're going to talk about the new style of computers. Hugh will continue to advance as it has done in the past thanks to our customers' voices. Please feel the advancement of Hue. All right, without further ado, we would like to introduce Hue. As Makino explained, I would like to introduce Hue, the system. It's an ERP featuring AI, and I'd like to demonstrate how this will change people's lives going forward. First and foremost, this is what I would like to introduce. This is something that we've introduced since the company forum 2014, but it's the search function. This is the very first one I'd like to introduce. I'd like to input a search word right here. Every time I enter one font, it will suggest all of these words. And the point is that this search, for example, HR system, accounting system, SCM, supply chain management, operation is not the only scope. This is doing a search within Hue. Every single piece of information in the Hue database is being suggested with a comprehensive decision of what I am looking for. With a priority ranking, the computer suggests the keyword for me based on the information that Hue has in the files, and furthermore, Hue has communication functions as well. For example, recently, it can pick up some kind of a word from a communication that was made very recently. And this is how the computer, Hue, continues to suggest these candidates. As you can see, until now, the computer that you've been using at home, your personal computers, what if you're going to serve a certain academic paper? Do you have to say, I am going to search a certain academic paper, so here I go? You don't have to put in this kind of information. You don't have to say, I am going to look for a company information. Please allow me to search for a corporate profile or overview. You don't have to put in these kind of pre-settings, but you do in ERP, in corporate in environments. In the ERP, you have to say, first of all, I want customer information. I want personal information of the employees from HR. I want to look at the evaluation results of the employees. And then you go and search for the person. But this is not the order that human beings think in. We just go flexibly and rather straightforwardly to the information that we want. In this case, when you input a certain keyword, you would usually think, what would this person usually be looking for? Probably this. For example, I think the first person that came up was a HR person, because the person who was inputting the information was from HR. And so the computer assumed that probably this person is looking for an employee, maybe depending on the name or the division. And under that, it says drive here. This is various files inside the Hue system, not just Hue, but also charts and word processing information. Even data from email is included in this drive. So Hue will also look for candidates from the drive. And as the demonstrator just mentioned, for example, until now, we didn't have such a thing. But emails within the company is all a part of ERP, right? And so from the communications, the email letters, Hue can also find keywords. For example, I think that it was that word, in that email, I think it was that company's personnel who changed roles. Who was that guy? I think he was something, but the memory is obscure. If you look at the field search result, you can see all of the emails and the messenger information that you've exchanged in the past. They are popping up as search results right here. You can see how unconscious you can be, just finding the word, and the computer is not forcing us to do extra work so that the computer manipulates. The computer doesn't say, okay, if you want me to work, first of all, you have to tell me what field you were looking for. You don't have to put in a field. What is a field? All you need to do is ask for what you want, and the computer does the work and says, is it this? Is it that? Or is it this? Yes, of course. And regarding the search function, for example, we're looking for fixed asset search. Let's do this a little bit more because this is related to the operation. So we're seeing this word asset search, and you can see the results, obviously. But now on top of that, Hue's AI is specialized on ERP. It's just for the company. So if you put this work, you can see the price. Is it 1 yen, suggested retail price, or is it the durability? These are some of the things that happens in a typical search for fixed assets. Is it already depreciated or not? You can find that according to your numbers. And also, this says air conditioning, and it's not just air conditioning, but maybe you're looking for an air conditioner or cooler or something. So it again suggests things that are suited for your work. Even if it's an air conditioning, in the same keyword, maybe you're searching for a business partner.
So in the past, for the air conditioning business, the suppliers would show up, and also the person in charge, and also the past record would be coming up. So all those things relevant to your work will be displayed. And also the search on the human resource system, and let me try one. Let's say a manager. It says sales. So these are the keywords. So these are the database entered words, and it shows up and it says the promotion candidates. So it's not in the database for those candidates for promotions, but this is an AI specified in operation. So it understands the definition of this word. So it gives you the list of the candidates for promotion to be in the sales department as a manager. So it gives an output based on the past record. So this is the operation of work-specific AI. This is a key point here. So I mentioned any keywords you enter, and you can do a search. But if you narrow down those words, so let's say if you're working on a fixed asset, and then if you want to leverage the AI related to the fixed assets, and if you talk to the terminal, and then as long as it detects that, this person is looking for something relevant to fixed asset, then that he's assuming the fixed assets, whatever he enters the next. So this is about the human resource. So doing a talent search on the human resource, and so this is the data already in a database. So the narrowing down the candidates for promotions for the managers for sales. So, but as soon as you enter this keyword of the promotion candidate, so then it understands that you are looking for information for the candidates. So the AI makes the judgment. So we have taught this definition of a concept of what the candidate means. So in a sales rep job, and who got what kind of evaluations and what kind of process we went through. So that will be taken into consideration. And the AI defines itself. So as a result of the definition, on the left-hand side on the screen, it shows these conditions. And it's possible to alter this. And once you alter it, and this result would be learned as well. It will be recorded. So once you repeat those kind of work, and the computer would understand that, this person wants to look at the more broad result. And the next time that computer would prioritize that kind of information next time. So it has a learning function that way as well. Okay, next, another representing function I would like to introduce. And this function has been introduced from 2 years ago, and this has been really well received. For Hue, it has a function of a spreadsheet. And I will show you this function. So what's shown here is the spreadsheet, but it's 100% compatible to the general spreadsheet. So you can create a frame and draw lines, and also you can enter functions and so on into calculation. And so let's say if you're using this for your actual work, and in a budget season, and So you develop this budget on a spreadsheet, and you need to calculate and so on. I believe you do this. And for using the spreadsheet function, the best characteristics of this is that it has a perfect fusion with the database. So as I mentioned, so creating a format and distribute it and then collect it. So that kind of work could transform drastically. So I'll show you a simple example. Let's say at the end of the year, these are the, let's say you want to know how many calendars you need to distribute to the customers. And then if you want to calculate it and then you create a format and then distribute it to each sales rep. And these formats you created in the past, you created on Excel, and you needed to attach it on the email, and you needed to summarize the result as you collect the result. But these are the people who got distributed this spreadsheet, and it says, there's a suggestion saying that please register how many calendars you need, so you don't need to attach on the email because it's integrated with the database. So you just need to click this submit button here. So you can enter easily, but not only that, but for the collection, it has a great advantage. So because it has a perfect integration with the database. So in the past, you needed to download it and you needed to fill the cells and in the past, but you will be able to do that on this sheet. So on the administrator's page, you see this. So those distributors, how many have seen the details, and and you can send the reminders to those people. And the people who have seen these notification, and you'll be able to confirm the results. So you no longer need to do the copy and paste kind of work. And of course, coming up with the total numbers and the calculations, you can do that easily. So without any structures of the programming, just by being connected to the database, that you'll be able to do this so easily. This is one of the great advantage of a queue. It might have been a little difficult to understand, but the biggest characteristics of queue is that. So the customers are working on each individual terminals and using different functions, emails, and so on. But that kind of work is actually monitored or supervised by AI on a real-time basis. So the AI is monitoring and watching what you do. So let's say when you distribute something and someone's opening the file or someone's started entering or left the desk, and that kind of information is monitored by the AI continuously, and then it controls. So, we have a messenger software, but someone has read it, but then haven't replied yet. So, of course, that kind of information can be obtained because on a real-time basis, the server or cloud side is monitoring it. So, you get the information like, everyone's read your information or email, but no one's replied. So someone is working on this operation, but he is on stall and so on. So that's recorded, but it doesn't mean that you can see all the kind of information. You need to have an authority to do that. But with a spreadsheet in the past, that you send an email with a spreadsheet attachment, and you didn't know if the recipient has seen it or not. But with Hue, with AI understanding and monitoring on a real-time basis, you will know that if the recipients have, opened your email or started entering the numbers and so on. So I am after introducing those representing functions and characteristics of a Hue, and I would like to talk about how Hue makes your life more convenient and easier. So now I want to show you the sorting function in accounting. So let me open this account. So the Toranomon for this facility. The Mori building number 11. Let's make a reservation and book this venue to say save some budget. Then if you try to do that, then in the past, then someone needed to build this kind of function in. But with an operation-specific AI, it voluntarily suggests what you should be doing to be more efficient. So how does this suggestion come up? So that the word rent is included in the slip. So the rent means it will be posted at the same timing and the same amount. So the AI has that kind of basic knowledge. So reading that kind of keyword, and it suggests that this kind of automation is possible. And of course, this is not only done from the operation knowledge, but if some work is done repetitively, and let's say from OE building, and you needed to allocate this cost to the affiliates, and so the AI learns that on this month and last month that you have done this, so you will be doing this next month and onwards. So it makes a suggestion. If you do this, you will do this. You'll be able to do this more conveniently. So this can be only done by AI. So you don't need to do anything. So as you engage in your work, and your work becomes more efficient and more convenient. Okay, let's say. I will show you more examples that your work will be more efficient. So this is one of the functions our customers have expected. So this is the offsetting the payment. So this is the function to check if your supplier or the business partner has made a payment to you or not. And then let's say if it's a payment made by an unknown partner, and then not only giving you an alert, this is an unknown payer, but also if the information matches with the master file, and it gives you an alert. And also, it identifies the cause and it makes suggestions. So if there's a gap on amount, on expected amount, and actual paid amount, and it gives you a suggestion as well, and also for similar alerts as well. So by speculating, looking at this result, and so there is could be a delay by a month. So even basing on the one phenomenon for those kind of transactions, that there could be many different kinds of causes, and it provides you a support so that you'll be able to identify the cause and make a right judgment. So I will show you another function which makes your work easier. And for the payment offset function, and it doesn't only identifies the gap, but you would like to know prior to the payment date that. So for this kind of transactions from your business partner and from this person, that this amount would be paid, and you would receive that kind of notification prior to the day. And you would receive that kind of massive data prior to the payment date. So the reconciliation with that kind of information will be done. But it was not done in the past because the format was different company by company, and the format could change without any notifications. So that's why that it was too cumbersome. So that's why it did not develop this kind of anticipation. But with the magic import function of Hue, you will be able to import this kind of information at once, and it reconciles with an information on the database, and it makes an analysis. And now it's reading information at the moment as well. And then let's say there are 3 items which could not be mapped. And this is a different format to the previous examples, so that's why that it suggests to confirm. And also for the AI suggestions, so these item mappings can be done easily. So the system cost doesn't need to be spent, and also it copes with the new changes to secure efficiency. So in the past, so this kind of a payment notification was sent to you, but it makes a suggestion. So leveraging this kind of information and so on. And I believe there are so many other work you'll be able to leverage this function, leveraging the external data. And I will show you one example. And often we receive this request from a human resources department, and the registration of the human resource information. Well, for recruitment, and often companies would like to register the information, the applicant's information, and then the HR would like to analyze the information of the applicants, and then let's say that each applicant would submit this kind of text information, the CV, resumes, with the different formats. And you will not be able to enter this kind of information, including text. So as long as it's on a paper base, and you know that you just saved it and you filed it, but until now. But as I mentioned, these kind of information can be imported to you, and then once you do that, even if it's not the set format, it makes a judgment where the information should be entered and so on. So this kind of information which you could not capture in the past can be leveraged now, and you will be able to import it in your own system.
完全にフォーマ
You can see that the format is completely free, liberal format. If it's an entry site on the company's homepage, people will enter their information and they will fill all of their forms according to what you're supposed to put into the field. But this one is a completely free, open format. But this information is very important when you, well, assign them after you hire them. And you will have to collect this information anyway. It will be in your computer, or it will be on a piece of paper in the worst case that you have to save somewhere. And you have to look at what's written inside and the position on the format in the field. I see. So this person is writing her motivation and the reason why she wanted to join the company. This part is where she is writing about her CV. The computer does the decision as to what is written. I think you would have more wishes and hopes about what kind of information you can deal with and accumulate into your data, and Hugh will realize that. So even if you have a system, we used to have a case where the information inside the system was not very well equipped, so we could not deal with the information well enough. But these kind of problems will be solved with Hugh, because Hugh will continue to learn with its AI capability and continue to give us better and better suggestions. For example, right here there's a screen that says sales department head. You can see that we're looking for a successor. This is a screen that is managing the information about succession plans. A person that will take the position of this sales division head, who has been the past sales heads in the past. All this information is collected here. The information that we obtained when we hired the person, all the way to the communication that they exchanged inside the company. What did they say? What kind of information did they deal with? All this information will be collected in a form of big data. And the more the big data is accumulated, the AI will learn more accurately. And with more abundant information, the suggestions and predictions will become even more accurate. For example, when you look at the communication and the things that they've been talking about, maybe as a succession plan, the next sales department head that you're looking for probably has to have these kind of capabilities. This is probably the type of person you were looking for, correct? Wrong? You know, it will give all these suggestions to the user, and this is exactly what we wanted. Strategic information that allows us to handle information for creative work. Now, I introduced analysis right now and some basic functions in a very limited amount of time. So regarding Hugh, the information that we provided to you today, I'd just like to say at the very end that Hugh system is already being delivered to overseas countries outside of Japan. So the language is also being translated. Hu's AI will continue to learn these languages as well so that we can change work for everybody around the globe. As my demonstration part, the ones I will show you will be the very last parts. I have been able to introduce various functions, features, and the way the AI memorizes and stocks the information about what we inputted. Now I'd like to introduce something called bot. It is a bot function that utilizes all of the information that has been collected up to this point. Specifically, it is called Talent Search Bot, which I'm going to introduce. Bot is a little bit of a technical word here. Let me interrupt. So you're talking to the computer. The bot is answering to you. You're talking to the artificial intelligence of the computer, and it's called the chat bot. But behind the chat bot, there's the artificial intelligence from the HR division, or whatever it is that you're trying to use it for. So here we introduce this. So we're saying, hello. It seems like you're working very long hours this month. This is not a fixed format. This is a sentence created after the AI has learned from how much this person has been working. And it actually talks to you like it's beside you and is trying to support you. Is there any problem that you're having at work? Well, let me know someone who is an expert on AI. Oh, yes, here are the people who have a background on artificial intelligence inside this company, 24 headcount. Would you like to see the details? As you can see, the very accurate analytics will also be done as well. So if you ask more about this person, you will say, this person probably is the best fit to meet your request. Okay, then how about deep learning? Who knows a lot about deep learning? Well, unfortunately, there is no person who knows a lot about deep learning, but it doesn't say that's the end. It will continue to find more information. Maybe you can ask in Talent Search, or here is a format that you can use to call out for people who may know a little bit more about deep learning. So it will continue to help you, give these suggestions to you to be helpful to you by providing information that you might want, or collect the information for you instead of you having to search for the information. So really, artificial intelligence is beside us, working together with us. And that day will come in the very near future, we feel. I've been going through these demonstrations very quickly, but that's all for the Hue demonstration. We had some new features that we introduced, some familiar ones from the past that has been improved and advanced thanks to the customers' voices and requests. Currently, we continue to listen to our customers' requests and voices to reflect that into the betterment of our product, and we're using more and more AI in our product. You can see the new figure of computers, not people being used by computers, but people using computers at ease, and the computer doing as much as they can on behalf of a human being, and it will change our lives dramatically. He was just one form of this big transformation in work style. I'd like to stop here and introduce a special guest. It is one of our customers who have jumped to Hue at a very early timing and also very motivated to change the company. There are two leaders from two companies. The first one is from MOL Information Systems. This is Mr. Nobunaga Shima. Mr. Nobunaga Shima, Representative Director and President of MOL Information Systems. Mr. Shima, please. Thank you very much for your introduction. My name is Shima from MOL Information Systems. Today, I'm very honored to be here at Company Forum 2016 from Works Applications. I appreciate the invite. As was introduced, we have decided to adopt Hue and currently working on the implementation as we speak today. Up until today, we have been using a packaged HR ERP system, but we had to roll it over and renew it, and we wanted to change it to Hue. So I'd like to share with you our experience about our decision making to implement Hue. I'd like to show you my next slide. Yes, MOL Information Systems. We are a part of Mitsui OSK, and we are in charge of the information systems. So I am also the decision maker for the system-related investments, and I do report to the CEO of the parent MOL company, which is a big group actually with various affiliates and companies under its umbrella. Various types of business is run, and our business footprint is very broad as well. Forwarder, ship management, shipping, ferry, cruise ships, and container ships, various diverse portfolio of work is being run under this group. And there are some other overseas local offices as well that we've not been able to list up on this slide. In the past, each and every one of these companies were responsible for running their own IT systems. But recently, we are facing the challenge of having to be more efficient and much more quicker in our management of the whole group. And that's why the IT also is required to link together so that all of the information is shared under one MOL. All of the IT systems and the ways that we used to work in a siloed manner is being improved as we speak today. I'd like to go back a little bit to talk about the MOL HR system. It was AS400, and it was doing the HR system for the workers on the ground and on the marine ocean as well. And they were separated. The systems were run independently, but up until March of 2013, we ran this project to integrate it under one company. It was a very old system, two systems that have been run separately for decades, and it was not easy to integrate them into one. The first target of operation had to be delayed about 5 months. And when we decided that the green light has to be delayed for 5 months, the top management gave us a very strict look. But despite this delay, we were very happy that we chose Company from Works Application because it performed so well, and we were very impressed. And Hue, the successor product of Company, has been launched, and we are paying attention very much to Hue as well. I think it will be in the future where MOL and the affiliate system companies' lifestyle will have to be considered. And in a very timely manner, we would like to introduce Hue and get the best benefits out of this new system. In order to do so, Hue's cutting-edge technology and new features need to be learnt by our employees so that we can use it to its best. MOL Information Systems will, first of all, have decided to use Hue after we tried it out, and we thought about the scale of our business, and we fed back. Well, we would like to feed back the effect of that going forward to the parent company. Beyond this process, after we sort of evaluate the performance of Hue, we would like to continue to see Hue being used in various other companies and below our group. As we say in our word, one MOL, We'd like to make sure that the IT system is integrated by geography or by functions under one umbrella so that we can gain the best benefits out of this system. Moving on to the next slide. We hope that the things that we could not do in the past will be enabled in the future by Hue, because we hear that the Hue is going to add on new features one after another to solve new challenges and accumulate more and more data. Understand that we can use this data in many, many layers in the future with more depth. We have very good feelings about the future. Now, on deciding the implementation of Hue, these were our thoughts. We have been using Company already, and there were no negative problems, not at all. And on top of that, Hue, the new product, is coming up, and the new attractive product has been launched and revealed in front of our eyes. So we had this very strong desire to see this new product as soon as possible. We understand it's a new product. New products and new services always come with uncertainty. Yes, we do feel that uncertainty as well. But having said that, we can't just wait for someone else to use it and to later tell us how it is. I don't think that's good enough. And I think there's a limit to waiting and seeing.
And if that's the case, then we needed to do it by ourselves. So that is the kind of thinking we have applied. So in my slides, it says challenging. But it doesn't mean that we are going to take risks. Well, if we work along with the Works applications, and we see no issues. And next. So this is our expectation towards Hue. So we would like our users to be delighted, and we would like our customers around the world to say Hue is fantastic. That's all I wanted to say. Thank you very much for your attention. Thank you very much. So I felt a strong commitment for challenge. And with Hue, we would definitely want to materialize that. And we have another guest speaker today from Kajima Corporation with this mission-critical systems they have implemented the rejuvenation project. And I would like to invite Mr. Uchida from Kajima Corporation. So from Kajima Corporation, he is Mr. Ken Uchida. He is the finance deputy director. And my name is Uchida from Kajima Corporation. And now we are working along with the Works applications. And this spring that we have, we just started up on a project to implement the Hue, and this has just started. And I would like to introduce some parts of our history working with Works applications. And our system, well, this is going to be the 4th generation on the accounting system. In the late 1970s, and we had those key punching systems. It was an old system. And in the 1990s, and with the mainframe, using the mainframe, and also the accounting logic was developed proprietary. So we had this enormous system. But then as we entered the 2000s, and there was an evolution, advancement of the technology. So with the servers and client PCs and webs, and that we have replaced. And that's the 3rd generation. But this 3rd generation, well, for the design logics and also the ideas and frameworks of data, those things were just the same as the 2nd generation. And as for of today, we've been using the system for almost 20 years. And as explained, the AI technology has emerged in the market. And to cope with this period, we needed to look for a system which is compatible to the world in this period and as an accounting system. And we encountered Hue. So I'd like to introduce my company. So it was established in 1840. So we have a history of 175 years. And we are headquartered in Emoto Akasaka in the Minato ward. And we do have 12 branches nationwide. And also we do have overseas business for civil engineering. And also we do have overseas legal entities. We have 4 of them in the US and in the UK. And Southeast Asia, and that's in Singapore, and also another one in Australia. So around the globe, we do conduct business. So our sales is the 1.7 trillion yen, and then 90% of this comes from the construction. The remaining 10% is from the development business, and we do have the 15,000 employees. This is a consolidated figure, and as you know, we are a construction company, so we do have enormous supply chain. So the people who are engaged in actual business is more than 10-fold of this number. So we work with affiliates a lot. So civil engineering and construction business, those are the 2 main pillars of our business. So this is a subcontracting business. And also on the right-hand side, we are working on the environmental preservation. And also this picture shows this is the Shirasagi Castle. And this was the restoration project of the Himeji Castle. This has been a hot topic. And we tried to restore as is back then, and it became too white, and it caught much attention. And also we have worked on the Tokyo Station as well. So on the bottom row, so that we do implement measures for the earthquake preventions. And also after the earthquake, we work on the restoration business as well. And also the reducing the natural disasters that we are engaged in research and development measures. And also for general contractors, that we do have this developers business as well. And relatively, we do have a broad range for this business. And also, as I mentioned, we do have overseas businesses as well. And I mentioned the revenue is 1.7 trillion yen, and to tell you what kind of scale that is. Then in terms of numbers of actual sites, is we do have about 1,000 construction sites a year nationwide, and we had 1,200 projects from 100 million yen scale from the bottom to the 100 billion yen scale. So in this kind of a business, well, what's our approach for our accounting system? So we are engaged in social infrastructure business and also the industrial infrastructure business. So very relevant to the constructions and providing support from that aspect. So, it's a manufacturing business, and our methodologies and technological evolution would take place in a market. And our business is a kind of business that we will be able to continue for many years in the future. So in a bracket, it says that we are creating the centennial, the 100 years, but that this is our copy as a company. And of course, our mission critical system or the accounting system needs to be a system which would lead us to continue our business for the next 100 years. So in that kind of approach, we encountered Hue. And we do have a massive revenues, and we used to have a system which supported this business for the last 20 years. That was the third generation system, as I mentioned, and it was a proprietary system. So in recent 20 years, well, we had some, updates and then some function additions and so on. So it ended up becoming such a complicated system. So that we have also implemented some industrial specific functions and some of the legal changes that we needed to cope with and so on. So in terms of the extendability or expandabilities, we are reaching a limit. And we encountered Works applications in that situation. And we decided to take a challenge to implement a packaged system for accounting and also for the regulations updates. And we felt the limitations to cope with those changes just as a company. So we have decided to adopt this packaged system to make it complete. And also the system maintenance itself, that we have decided to outsource it and leverage the external capability. In this kind of process, and what we expected Works applications to do and what they presented to us is shown here. And from the beginning of this session, there was a great demonstration, and I felt the significance of the AI and developing the forecast of the entry words and also the fast processing speeds and so on, and leveraging the cloud and how to store the data, and also being able to update the database on a real-time basis. So that kind of a technological backgrounds and advantages is combined with the Works applications experience working with the various companies in the past. And so we have expected the Works applications to replace our third generation system with their cutting-edge technology. But not only securing the operability of this legacy system, but we have a great expectation so that our work would be more sophisticated. And the construction industry is a very specific. And then all the parts are made to order. And everything is manufactured based on that design. And as I introduced, I mentioned the number of projects and sites. And if we have over 380,000 formats, and we have over 1,000 invoices we are handling a day. And furthermore, the sites would change. Once the building completes and our workplace changes. So the data entry point would need to move as the project proceeds. So many people will be engaged in accounting work and management work, and entry work is very cumbersome. So if this process can be more efficient, and that provides much advantage to our work. And as it says on the right-hand side, for each one of the work, and of course we need to calculate the profit and loss. And then from looking at the design, that we develop the quotation of the cost, and then narrowing down that quotation, we develop the actual budget. So the cost always need to be referred to this budget, and it need to be managed. So within our old framework, we used to store data very in a dispersed manners nationwide, and at account settling timing that we needed to integrate all those. And also we had subsystems for the cost calculations, and they were not linked perfectly, so we could not capture the data on a real-time basis. So for that issue, with the hue of Works applications, everything can be updated on a real-time basis with one database. So the reconciliation with the budget became very quick. And that's something we targeted, and that's something we regarded very critical. So with some expectations for the future, and also in the future as we engage in our business, that we needed a system which we could use for many years in the future, maybe not up to 100 years, but we needed a system which would lead us to operate in the next 100 years. And also, as I heard in previous presentations, I felt this playful spirit which I wanted to use. So the users would love using the system. And I felt that watching the demonstration, and I would really expect the Hue to evolve that way more. And I believe and I expect the Hue to cope with the transformation of the transactions. But if we are working with the Hue, and if we engage in a dialogue with the Hue, and then that Hue would provide a trigger for us to transform ourselves. So that's my brief presentation. Thank you very much for your attention.
Thank you very much. It's really about work transformation. It's not us for make the work transformation. It's Hue and you that use the artificial intelligence of Hue to come up with your ideas. If Hue can process at such a speed, then why can we do this? Can we do this? How can we change our work if Hue can support us? I think this is the ideas that come up one after another. Every week we have new ideas about how we can change our work and work style. And this change is accelerating as we speak, with the endorsement of Hue in the back that will support us. Now, we had you see the demonstration of Hue, and I think you can either have one of the two opinions. One opinion would be, that's a good demonstration. This is something that is completely new in the enterprise systems in the past. But another opinion may be, wait a minute, aren't all these functions obvious? It's a given now at home on our smartphones. Both of the opinions are right. The challenge that we have made is unfortunately not that challengeable. It's just that it's very new in the ERP area. We are the first to do that. It has been proven. There are track records in the consumer applications already. It's just that we broke the thought, the conventional thinking that we don't need such sophisticated artificial intelligence in enterprise systems. We'll just stick with the systems that we have already. No, we said no. We should have this convenience in ERP as well. And we are the very first ones who brought this into the realm of enterprise. And the artificial intelligence is not the most important technology anyway. Actually, when we think of the analogy of AlphaGo, who is that system who won against the human Go champion, in order to realize AI, there is a very important piece of technology, and that is distributed processing technology. This is the key. This is the very important technology. Now, the system in AlphaGo, also Japanese artificial intelligence technologists were thinking about this. Probably, yes, we can beat a Japanese Go player, but we need to use a supercomputer and spend years and years to come up with such an artificial intelligence, because we have to teach the computer how to learn how to play Go and how to play Go better and better so that it can ultimately beat human beings. It will take years for a computer to be able to become that strong. But AlphaGo did that in very short time period. And that is because of distributed processing technology. Now, this distributed processing is a technology that has been around for a very long time, but it has accelerated in the past 10 years, the advancement of this processing, with having numbers of servers on the rack performing all together at once, so that it creates a performance that is even higher than a typical supercomputer. Distributed processing technology allows this to happen. You use a lot of big data, but the big data can be processed with very high response, low cost. It's like a dream with all of these servers working under this distributed processing scheme. For this kind of system in North America, or to be specific, Silicon Valley has been the leader in this. It's not Japan, it's not Europe, it's North America, and more specifically, it's Silicon Valley. And the startups that are popping up as we speak today are basing their technologies on distributed processing technology in the B2B area as well. There's many, many startups currently that are challenging this. Actually, for most of the cutting-edge technologists or the startups that are coming up right now, all use distributed processing technology. So if distributed processing technology is so wonderful, then why didn't we use it in ERP? We have it in B2C products and applications. Why don't we have it in B2B? Well, it's because there's one flaw in distributed processing technology. That is, it requires a lot of cost to develop because it's difficult. It's a very high-level technology that requires high-level R&D. All you need to do is come up with all these rules, to put together a conventional database. But distributed processing technology requires a very big database with various types of information stored inside it. So the people, the engineers who have to, write the codes and do the programming have to understand very high-level technology. So in a nutshell, we need a lot of R&D investment to break through with this power and the capability to R&D this. Facebook, Amazon, they do this very well. They have done this already so that we don't get sick and tired of doing shopping while we're on their site. Facebook has given us the comfort to glide through their contents with no frustration, and it's because they all use distributed processing. And Hue did as well. And the reason why we were able to do this is because we are the package vendor who provides packaged ERP systems to our customers. The two gentlemen who came up and spoke for us, who represent a big base of customers for us, have supported us. Because we have these many customers, we're able to develop this with a good distribution of costs. We're able to sell to many, many customers who support us, who are willing to pay their money to use us, has helped us to fund our R&D activities and to come up with this technology based on distributed processing. The other key is, in order to operate this with the lowest cost as much as possible, we newly developed more technology so that the engineers can easily, well, it's not easy, but relatively easily implement the technology. So what I'm trying to say is that we are not using distributed processing technology just for us. And this system has been made for our customers. It's not just for us. But having said that, this has not covered all of the work areas that our customers do in their daily life. There's many, many more functions that we need to cover and many more features that we need to provide to our customers, but we cannot come up with all of the features alone. And on top of that, if we are to keep the distributed processing to ourselves, then the customers will have to deal with us. But this is our thought here. We decided to completely open the Hue technology to the society. We call it the Hue's Pass because we are going to provide the development environment to the IT divisions of our customers and also system integrator companies as well. We're going to open up Hue so that everybody can use it on the platform. We have engineers from Singapore today, so we actually I would like to actually call them up on the stage to give them just a flavor of how the development is done in regards to PASS. Yes, I'd like to introduce Hue PASS right now. This is the screen. This is actually the inventory system. It uses the same distributed processing technology as Hue. So we have 10 million worth of search information. You can see that you can do the search operations with no frustrations at all, like you saw in the previous demonstration. And you also saw in the previous demonstration the convenience that you get with magic paste using AI, or the co-editing and the distribution of information on enterprise spreadsheet. You can use the same features here on this PASS as well. And Hue PASS enables our customers to develop their own. This has the real go-live environment and the production environment monitoring tool, test tools, and data resource tools. In the environment, we have various support tools to help you along the way. So today I'm going to show you the screen design tool, the database tool as well. First of all, this is the design tool that you're looking at right now. This is something that you can design while looking at the preview screen. It's not just a generic web component. We have the components specific to work, and also some components that are the special features from Hue. For example, ESS, the enterprise spreadsheet, which can be activated like this. You can choose the items here. There's also a magic paste function where you can do the tuning of AI. Now, what I mean by tuning of AI is to work on the types of algorithm for the machine learning, or work on the ledgers specific to work is processed with clustering, so you can do the setting for the clustering process as well. And if you have various other information that you want to deal with, you can use a separate tool to continue to read in the information that you want to input while you are developing the system. Let me interrupt here. I think if you don't belong to the IT division, what he is demonstrating right now may be a little bit of a mystery for you, but please bear with us a little bit. Yes. So now, when you develop the subsystem for the ERP system, you actually do not have to develop from scratch in most cases. For example, if you're going to just refer to an information or approve an application or something, it's a pattern. You do these routine work all the time. So Hue PASS will learn from these work patterns and create a template specific to work. And you can start not from scratch, but from these templates in your development work. We have the bot and the distribution batch as well. These are some of the templates that we have provided for the back-end work. Next, I'd like to introduce the collaboration tool. Hue is an IDE, so it's JavaScript based on Eclipse. So you can develop this with Java or JavaScript. The features that you see on the right side is the suggest feature. Now, when you do coding, there are certain disciplines, and you write according to the codes, according to the disciplines. But if you have the discipline already ready for you, then you can easily do the coding. But sometimes you cannot find a good template, a good pattern, or even if you do a little research on the internet, you cannot find the right code for you. I think this has always been one of the struggles of the developers. But of course, we will ask for permission to collect the information, but we can share these disciplines together with the developers. For example, the work template that we chose, or the source code that you're just working on right now. We will choose, Hue will choose the appropriate template for you, depending on what you seem to have been doing in the past. This is all about the environmental development environment. And I think this is like an infinite loop kind of debate that we always have. But artificial intelligence has come a long way. If you can do all of these things, then why do we even need human beings to begin with? We always talk about this. Why don't you just let the AI do the whole programming? And the experts say it's impossible. And I go, why is it impossible? It's artificial intelligence. Why can't they do all the programming for you? Well, they say, with the current level of technology, it is still difficult. But with work, and everything else, we still need human beings. And it's not like the artificial intelligence can rule the whole work for us without human beings. There are these judgments that we need to make. There are these rules we need to apply. So that's why not everything can be automated by the artificial intelligence. But it's much, much better, because you would copy and paste and write and edit these codes with a tremendous amount of time spent. But the artificial intelligence will follow you up on whatever step you take. They will watch, and they will understand the logic of what you're trying to do and say, isn't this the logic that you're trying to lay out right now? And with this kind of suggestions, it will dramatically improve your productivity. This is the kind of R&D we've been doing in the past 12 months. And as a result of that, we have this suggest function that you can see on SAS. As a program editor, it's kind of like a very talented editor guy who is giving you all these suggestions. That's what it will feel like. Yes. And the next one that I'd like to introduce is something that is very difficult to do alone. Because it's always a project, right? When you do a system development in a corporation, you will have not a few, but tens of people working on the program. Everybody has their own personal computer, your own execution environment and go live environment and all of that. And, it's a common sense that we have our own environments and our own computer, but not for Hue. Hue PaaS provides one environment for multiple number of engineers to share one environment among everybody in the project. And the reason why this is good is because, for example, when you think about the cost and the stress to develop a development environment, you can remove that. That's one reason. And the other reason is communication. Since the development environment is different, you don't know what the other person is developing right next to you. It has been a given. It has been the way things were in the past, and we have given up. We thought that was the way it's going to be forever. But that is where we have the communication gap. And it will be solved with the Hue communication features. Obviously, even if someone is in a remote area, you will still understand what that person is developing as you're just like you're right next to that person. And furthermore, as you can see on this demonstration, if there's a problem with one source code and you have to ask someone else for a correction, you can ask that person to do that. But you can continue to chat with one tool and keep looking at the same source code.
So you'll be able to engage in such dense communication with them. But if someone inputs an error, and if with one source code, and if multiple numbers of people enters the wrong source codes, and what happens might be your question. And this is a collaboration package, so PaaS. So there is a function called activity log, and that's where you can identify who did what, and you can go back an hour ago, and then you'll be able to edit again. So lastly, there's a database tool. And we have a Cassandra, Elasticsearch, Kafka. So those the distributed processing technologies are integrated, and we do have our proprietary framework. And then so you will be, developing using this Hue PaaS. And the reason why we have combined all these framework is because, for example, for Cassandra, so to be able to develop a simple application, it's okay. But to be able to develop a complicated ERP function, and there are some limitations you face. So to be able to cope with those complicated requirements, we combine these. But the developers should not feel that. So in a database tool, so without being aware of this kind of the complications, you'll be able to develop easily. So this is the tool. like that. And as one of the characteristics is that you'll be able to create the test data. So this is leveraging AI as well. And what becomes the stress for developers is it's about developing environment and so on. But the testing is another factor. If you want to create the environment which is the same as a go live situation, or if you want to develop a SMAP patterns and so on. And so to be able to cope with that kind of requirements, let's say there is an engineer created a table, and there are similar tables on Hue, and it provides some suggestions of test data. So it eliminates the complication here as well. So the complications and difficulties of the distributed processing technologies that those stresses that we developers used to feel could be eliminated with HuPass. So if you're a non-engineer, that must have been terribly boring. But for engineers, well, domestically in Tokyo and Osaka, we have locations in Shanghai and Chennai, in India and Bangalore, and so on. You know, the engineers are conducting the distributed processing technology development, so they need to update the source codes with this methodology. And with this, we could improve our efficiency. So that's a key point. So next year, we think we'll be able to provide this HuPass next year. So look forward to it. And so please understand that because of the distributed processing technology, there's an AI. And the technology would evolve in the future with the distributed processing technology. You know, as we collaborate, those SNS, changed your lives. And that's because of the distributed processing technology. And it's all gifts of this technology. So please join us in this evolution. So after this, we would like to invite the most prominent person in AI in the globe, and this is our first time for him to lecture in Japan this way. So we would like to welcome the Dr. Ray Kurzweil, and many of you are here just to listen to his lecture. So please enjoy your time with his presentation.
この後は
So after that, we will be having a presentation from Dr. Ray Kurzweil. Ray Kurzweil is one of the world's leading innovators, thinkers, and futurists. And with a 30-year track record of accurate predictions, called The Restless Genius by the Wall Street Journal and The Ultimate Thinking Machine by Forbes magazines, Kurzweil was selected as one of the top entrepreneurs by Inc. magazines, which described him as a rightful heir to Thomas Edison. PBS selected him as one of the 16 evolutionaries who made America. Kurzweil was the principal inventor of the first CCD flatbed scanners and one of OmniFront optical character recognition, the first print-to-speech reading machine for the blind, and the first text-to-speech synthesizer, the first music synthesizer capable of recreating the grand piano and other orchestral instruments, and the first commercially marketed large vocabulary speech recognition. Amongst Dr. Kurzweil's many honors, he recently received the 2015 Technical Grammy Award for Outstanding Achievements on the field of music technology. So please welcome Dr. Ray Kurzweil with a big hand of applause.
It's a great pleasure to be here. This is my 5th trip
to Japan. Japanese cuisine is my favorite cuisine, and I'm enjoying your hospitality and have been following the technological advancement of Japan for many decades. And I'd like to share with you, building on what Mr. Makino shared with you about the future of intelligence. You may have noticed that artificial intelligence has risen very substantially in the last few years. I've been thinking about this, thinking about thinking for 50 years. When I was 14 years old, I wrote a paper on how I thought the human brain worked and how we could build artificial intelligence in the same way. And I described the brain as a series of modules. I didn't count them, but we have many modules. Each of these modules can recognize a pattern of information. It learns a pattern, it remembers that pattern, it can recognize that pattern, it can implement that pattern, and these modules are organized in hierarchies, and we create that hierarchy with our own thinking. That's as far as I got 50 years ago. I won a science contest, I got to meet President Johnson, and I continued to think about this issue for 50 years. 50 years later, 2012, I wrote a book called How to Create a Mind. Now we have an explosion of neuroscience evidence that supports that thesis. There was very little to go on 50 years ago. And now I've counted the modules. We have 300 million in our neocortex. The neocortex is the outer layer of the brain. That's where we do our thinking. And we know enough about these modules to actually describe how it works. So I described the algorithm. I described it as a hidden Markov model. And we create that hierarchy with our own thinking. And I described how we can do artificial intelligence in the same way. It's a little bit different than the deep neural nets that are now being used, although we can use deep neural net technology to implement this. So I gave an early version of the book to Larry Page. He liked it. I met him and asked him for an investment in a company I was going to start to implement these ideas. And he said, well, let me give you a better idea. Why don't you do it here at Google? We've got lots of computers, we have lots of data, we have lots of talent. And so I took my first job for a company I didn't start myself about 4 years ago. And it's been a great experience. And we're applying that to understanding human language. Human language is actually the greatest challenge we have. 2 million years ago, we got an additional quantity of neocortex with these big foreheads. Primates don't have these foreheads, they have a slanted brow. So we got an additional quantity of neocortex and we put it at the top of the hierarchy. And that was the enabling factor for us to invent language and art and science and music. No other animal has music. Every human culture we've ever discovered has music. Humor, only human beings are funny. That comes from that additional neocortex we got with the frontal cortex. But that was a one-shot deal. Our skulls got bigger. That was a challenge for childbirth. We couldn't expand it anymore. We're going to expand it again, but not by making our skulls bigger, but by actually connecting to the cloud, and I'll come back to that. So let me share a few key ideas that sort of shape my thinking and are the basis for my futurism. I discovered the law of accelerating returns over 30 years ago. In 1981, I realized that the key to being successful as an inventor was timing. You had to be in the right place with the right idea at the right time. And I started with the common wisdom that you cannot predict the future. But being an engineer, I gathered a lot of data, and I thought if I visualized them with the right tools, squinted at the visualizations, maybe I could make some educated guesses. I made a very surprising discovery. If you look at the price, performance, and capacity, not of everything, not of every technology, but information technology, it's very predictable. And what's predictable is that it progresses exponentially. It doubles in power about every year. Our intuition about the future is not exponential, it's linear. We expect things to go in a linear manner. A linear progression goes 1, 2, 3, and at step 30, you're at 30. That's our intuition about the future. An exponential progression, that's the case with computers, with communication, now with biological technologies, with things like genetic sequencing. It goes 1, 2, 4, but at step 30, you're at 1 billion. Step 40, you're at 1 trillion. This is not an idle speculation about the future. This is several billion times more powerful per dollar or per yen than the computer I used when I was an undergraduate at MIT. It's also 100,000 times smaller. We'll do both of those things again in the next 25 years. These will again be 1 billion times more powerful for the same cost. They'll be 100,000 times smaller. They'll be the size of blood cells. Gives you some idea of what will be feasible. So here's the graph I had in 1981. I had it through 1980. This goes through 2010. We just updated it to 2014. It's right on track. It's amazing how predictable this is. I had it through 1980. I projected it out to 2050. We're now in 2016. 35 years later, it's exactly where it should be. This is a logarithmic scale. As you go up the y-axis, we're adding zeros, orders of magnitude. Every labeled level here is 100,000 times greater than the level below it. This is the price performance of computers, calculations per second per constant dollar. But look at how smooth a progression this is. People look at this and they go, oh, Moore's Law. But Moore's Law is only the part on the right. This started decades before Gordon Moore was born. In the 1950s, we were shrinking vacuum tubes to make them smaller and smaller to keep this going. That finally hit a wall. 1959, we couldn't shrink the vacuum tubes anymore and keep the vacuum. That was the end of the shrinking of vacuum tubes. That was not the end of the law of accelerating returns or the exponential growth of computing. It just went to the fourth paradigm, transistors, and now chips, which is the fifth paradigm. 2020, the key features will be 5 nanometers, which is the width of 20 carbon atoms. We won't be able to shrink them anymore. That'll be the end of Moore's Law. It will not be the end of this ongoing exponential growth. We'll go to the sixth paradigm, which is computing in 3 dimensions. But look at how smooth a progression this is. I mean, where are the great events of the 20th century? World War I, World War II, the Cold War, the Great Depression. People say, well, it must have slowed down during the recent recession of 2008. But no, I mean, it just keeps going. It has a mind of its own. Goes through thick and thin, through war and peace, and will continue going. And it's very transformative. That's why we have these constant revolutions. So in 1968, you could buy 1 transistor for $1. Now you can buy 10 billion for $1. And they're actually better because they're smaller, so the electrons have less distance to travel, so they're faster. The cost of a transistor cycle, that's a measure of price performance of all of electronics, comes down by half every year. That's a 50% deflation rate. And the economists worry about deflation. We had massive deflation during the Great Depression of the 1930s. The concern is if I can buy the same stuff that I could buy a year ago, same computation, same communication, same genetic sequencing, physical things, because I'll talk about 3D printing in a moment, I'll buy more, but am I going to actually double my consumption? After all, how much do I need? Aren't I going to saturate my ability to consume these resources? Well, it turns out we actually more than double our consumption. This is bits of memory shipped. I have 50 graphs like this in different areas of information technology. There's actually been 18% growth every year in constant currency, dollars or yen, despite the fact I can get twice as much of it each year for the same cost. And the reason for that is what you're all doing, which is creativity, innovation. We invent new applications. 10 years ago, people tried to do social networks, but the price performance wasn't there. Came into play 7 years ago, and that application exploded. I saw the advent of search engines. I said they would emerge in the late 1990s. I said that in the early 1980s. The internet didn't exist. The predecessor called the ARPANET existed. It connected 1,000 or 2,000 American scientists. but I saw it doubling every year. I did the math and said, wow, this is going to be a World Wide Web connecting hundreds of millions of people around the world to vast knowledge resources in the late 1990s, and there'll be so much information we won't be able to find anything, and we'll need search engines, and the computational and communication resources to create a search engine will be in place. I couldn't predict that of the 50 different projects to do that, it would be these couple of kids in a Stanford dormitory who would take over the world of search, but the fact that search engines would be needed and would be feasible, that was predictable. On the left there, that's internet data traffic doubling every year. That's a logarithmic scale. On the right, that's the number of bits we move around wirelessly in the world, going back 100 years. So there was Morse code over AM radio a century ago. Today it's 4G networks. That's again trillions-fold increase. That's a logarithmic scale. Look at how smooth and predictable a trajectory that is. This aspect of the future is remarkably predictable. Here's that graph on the left that I had of the internet. I had it in the early 80s. It's a logarithmic scale. Predicted the World Wide Web emerging in the late 1990s. The graph on the right is the same data, but seen on a linear scale. And that's how we experience it. So to the casual observer in the mid-1990s, it looked like, whoa, World Wide Web, new thing, came out of nowhere, but you could see it coming. And it's not just electronics. It's ultimately going to affect everything. Our health and medicine is now becoming information technology. And I'm not just talking about computerizing medical records. The very basis of life is our genome. That's a set of software programs that evolved thousands of years ago. We now have the software of life, and we have the means of actually modifying it, changing it. We can turn genes off with RNA interference. We can add new genes. This is a long topic. We could talk all day about it. The enabling factor for this was the Genome Project. That was a perfect exponential. It doubled every year. The cost came down by half every year. Their first genome cost $1 billion. We're now down to a few $1,000s per genome. But it's not just sequencing, collecting this data that's expanding exponentially. Our ability to understand it, to model it, to simulate it, and most importantly, to change it is also expanding exponentially. And we now have lots of clinical applications. Half of all heart attack survivors have a damaged heart. Many can hardly walk. We can actually fix that by reprogramming adult stem cells. And there's many other examples, but this is going to revolutionize health and medicine. There's now a trickle of applications. This will be an explosion of applications within a decade. And this is going to dramatically expand our life expectancy. Supercomputers, Japan is very involved in this. This is a logarithmic scale. They're basically doubling in power every year for the same cost. But look at how smooth a progression that is. It's very predictable. Solar energy, that doesn't sound like an information technology, but we're applying nanotechnology to the design of solar panels. Larry Page of Google and myself did a study for the American National Academy of Engineering, and we noted that solar energy is growing exponentially. It's doubling every 2 years. Right now, we're only 6 doublings at 2 years each for meeting all of our energy needs, at which point we'll be using 1 part in 10,000 of the free sunlight that falls on the Earth. And 3D printing, it's a little early now. I think this will take off in the 2020s. We need submicron resolutions, but that's improving at an exponential rate. We'll be there about 2020. These are some things you can actually print out today. I co-founded Singularity University with Peter Diamandis and Larry Page, and we had an opening recently where every instrument in the band was printed out on a 3D printer. But this will revolutionize manufacturing in the 2020s. You'll be able to print out clothing, for example. And there'll be an open source market where you can get very cool designs for free, print them out at pennies per pound. That's the nature of 3D printing. But we'll still spend money for cool designs from the latest popular designers. Look at other industries that have already gone from physical products to digital products, like movies, music, and books. If I wanted to send you a music album or a book or a movie just a few years ago, I'd send you some kind of postal package. in the mail. Now I can send you an email attachment. But the revenues of those industries have actually gone up, not down, but fueled by the ease with which we can distribute those products, the ease with which we can promote them, using artificial intelligence to tell you what books or music we think you'll like, and so on. The shrinking of technology is also an exponential process. We're shrinking technology at a rate of 100 in 3D volume per decade. By the 2030s, we'll have devices the size of blood cells that are little robots with computers in them. They'll have three functions. One will be to go beyond our immune system. We have these little T cells that are natural blood cells that can fight disease, but they don't work very well, particularly for diseases that get us later on in life. Like, for example, cancer. It thinks, oh, that's me, and doesn't go after it. We can create an extension of our immune system that goes against all disease. Cancer, retroviruses, fix metabolic diseases, do microsurgery, get rid of plaque in the arteries. There's a scenario actually to overcome every disease and aging process using these medical nanorobots. That's the third bridge to radical life extension. That's a 2030 scenario. Another will be virtual and augmented reality from within the nervous system. So we have a virtual and augmented reality revolution starting now, not by going inside the nervous system, but with devices you put over your eyes, your ears, devices you can put on your hands and for tactile virtual reality. But in the 2030s, we'll go inside the nervous system and feed your brain directly with the signals that you would be getting in the virtual and augmented environment. And then it'll be extremely realistic, full immersion, and provide fantastic virtual environments. The third and most exciting application will be to actually connect our neocortex directly to the brain. I mentioned that this was billions of times more powerful per dollar or per yen than the computer I used when I was a student, but that's not the most exciting thing about it. If I want to expand this a millionfold, it communicates with the cloud, can access all of human knowledge with a few keystrokes. We can't do that directly from our brains yet. We do it indirectly through these devices, but we'll be able to do it directly from our brain in the 2030s. And not just to do things like search and language translation and finding products directly from our brain, but actually expanding the very nature of our thinking. So I wrote this book I mentioned, came out in 2012. I don't have time to describe it in great detail, but we have 300 million of these modules, each of which can recognize a pattern. They're organized in a hierarchy, and as you go up the hierarchy, issues become more complicated, more sophisticated. So at the bottom, I might recognize the crossbar to a letter A. At the top, I might recognize, a couple layers higher, I might recognize the word apple. Go up another 5 levels, and I might have a module that sees a certain fabric, hears a certain voice quality, smells a certain perfume, and fires, oh, my wife has entered the room. Go up another couple dozen levels, and you'll have modules that fire that says, oh, that was funny, that was ironic, she's pretty. You might think that those are much more complicated. It's actually the hierarchy below them that's more complicated. The 16-year-old girl was having brain surgery and talking to the surgeons. You can do that because there's no pain receptors in the brain. And every time they stimulated these points shown in red, she would start to laugh. And at first they thought they were triggering some kind of laugh reflex, but they quickly realized that no, they were triggering the actual perception of humor. Whenever they stimulated these points, she found everything hilarious. You guys are so funny just standing there was a typical comment. And they weren't funny, not while doing brain surgery, but they had found the points on a neocortex that detected humor. And we're going to connect our neocortex to the cloud to actually create more of these kinds of modules. We have 300 million of them. We got more 2 million years ago when we became humanoids and got this big forehead. But that was a one-shot deal. When we connect to the cloud, that'll be an unlimited amount of neocortex. Our thinking then will be a hybrid of biological thinking and non-biological thinking. But the non-biological part will be subject to the law of accelerating returns. The cloud is doubling every year now as we speak, so it'll keep getting bigger and bigger. More and more of our thinking will become non-biological. So we will become smarter, we'll become funnier, we'll become better at music, we'll be better at expressing loving sentiments, and we can back our brains up. That's the fourth bridge to radical life extension. We're applying this to language. You may have heard of, in America, the IBM computer Watson was able to win at this very sophisticated knowledge and language game. And we're going to ultimately expand our longevity. I talk about in my books 4 bridges to radical life extension. Bridge 1 is what you can do right now. Bridge 2 is biotechnology, reprogramming our biology, which I mentioned, and that's now entering a mature phase. We already have clinical applications. It's a trickle now. It'll be a flood in 10 years. Bridge 3 are these medical nanorobots going inside the bloodstream and extending your immune system. Bridge 4 will be to connect our neocortex to the cloud and ultimately be able to back up the information in our brains. We're only about 12 years away from a tipping point called longevity escape velocity, where the scientific progress will be expanding our remaining life expectancy faster than the time going by. So you go forward a year, your life expectancy will move on away from you. It's not a guarantee, but the sands of time will start running in rather than running out. So if you can hang in there for another 10 or 15 years, we may get to experience the remarkable century ahead. Thank you very much.
Kurzweil さん、ありがとうございました。
Thank you very much, Dr. Kurzweil. So from here, that I would like to invite Mr. Makino, the CEO of Works Applications, up on the stage to have some discussions with Dr. Kurzweil.
それでは牧野 CEO。
So the CEO Makino, please. Thank you very much for your great presentation. Singularity, the word, for us and for many Japanese people who are engaged in AI research, well, the singularity is becoming more real to us. Well, I believe so many of the audience would like to ask questions, and this is a great opportunity. Dr. Kurzweil is coming, and I have received many questions they love to ask you. So I would like to pick up some of that, as I talk to you today. So let's get right into it. Well, as Dr. Kurzweil, as prior to your presentation, we introduced our system, Hue, which is leveraging the artificial intelligence. And I would really appreciate it if you could give your feedback on our system, Hue.
Well, I thought the demonstration was very impressive. And AI is entering every field. It's been slow to enter ERP, so your company has been a pioneer in that, and it makes perfect sense to make company operations and communications and internal infrastructure more efficient and more intelligent by basically marrying human intelligence with artificial intelligence. So I think it's a great step forward, and I think it's going to sweep the ERP world.
Thank you very much. Okay, let's move on to the next question. Well, I believe you've been asked this question many times, but the timing of singularity, in your book, you mentioned, singularity is close and 10 years ago, and the AGI appears in 2029, and the singularity would come in 2045 with the AlphaGo winning and also the autonomous driving. And I believe that this law of accelerating return is, more accelerated. And I believe the time is coming faster than expected. What do you think?
It certainly seems that way, but it's really right on course. 1981, I had these graphs, and I projected it out to 2050. We're now 2016. It's right where it should be. So I wrote The Age of Spiritual Machines in 1999. I said 2029 computers would match human intelligence. In 2005, The Singularity is Near came out. So certainly there's been a tremendous amount of evidence just recently. You mentioned AlphaGo and autonomous cars, computers doing image recognition better than humans. So I think actually the AI field and the general public is much more in accord with my predictions. When I said 2029 in 1999, people thought it was crazy. Now people think it's quite reasonable. But I'm sticking with that date. 2029, computers will match the range of human intelligence. And then we're going to merge with it in the 2030s. It's not going to be some sort of competing force to compete with us and displace us. We're going to make ourselves smarter. That's why we create technology. I couldn't reach fruit at that higher branch 1,000 years ago, so we created a tool that extended our reach. And our tools expand our muscles. I mean, who by themselves could create a skyscraper? Well, we have machines that extend our muscles, and now our machines extend our intellect and our knowledge. We're going to merge with that technology and make ourselves smarter. By 2045, we'll expand our intelligence 1 billion-fold. That's such a profound transformation. We borrowed this metaphor from physics and call it a singular transformation, a singularity. But it's just going to be a continuation of the human civilization, which is already a human technological civilization, expanding its capabilities.
なるほどなるほど。
Thank you very much. In your book, you mentioned the same genes, nanotechnologies, and robots. Those are the very important aspects. And for those, so it hasn't changed since your the prediction. Is that right? Or do you see any other elements which are more important?
There are these 3 overlapping revolutions that sometimes go by the letters G and R. G stands for genetics. That's the biotechnology revolution I talked about, taking this old, outdated software that evolution created tens of thousands of years ago and updating it. And we're actually doing that already. I'm involved with a company where we add a gene to people who are missing a gene that causes a terminal disease, and that's actually cured this disease. We're growing human organs, actually using 3D printers and modified stem cells to create kidneys and hearts and lungs, putting them successfully in primates. This will be coming to a human near you soon. So that's G. That revolution is already underway. The next revolution will be nanotechnology. It's beginning. We're applying them to solar panels. Not yet being used in medicine, but I think by the late 2020s we'll begin to do that. By the 2030s, we'll actually have an extension to our immune system. So rather than just having our natural T cells, we'll have these robotic T cells. But unlike our natural ones, they will go against all disease. And that's, as I mentioned, the third bridge to radical life extension. R stands for robots. That's really artificial intelligence. That's already underway. We're using that in ERP and lots of other things. Certainly, your smartphone is constantly using artificial intelligence to help recommend products and songs and do search and language translation. And this is going to pick up steam. Go is a very good example of these are fairly narrow applications, but the narrowness is getting broader and broader. Driving a car is actually not so narrow a capability. It's a pretty broad capability. By 2029, it'll have expanded to encompass all of human intelligence. But again, it's going to be a tool to make us smarter and us more effective. That's why we create technology.
Yes. Thank you.
Okay, let's move on to the next question. So as far as you can answer is fine, but Google, they do not want to disclose so much information. So the many people ask you this, which is what's the research content, research themes of Google, and what's the target of that research? The neocortex simulator, I believe you're engaged in the research with the neocortex simulators. And could you disclose us what kind of research you're conducting related to that, as far as you can say?
Well, Google has taken its deep learning, deep neural net technology, and put it into the public domain called TensorFlow. And hundreds of thousands of engineers have downloaded it, and it's available to everyone. And Google does a lot of publishing, and so it's really sharing its research. I think the thinking is that then lots of people will contribute to it, and we'll actually make faster progress. The goal of Google is the same as every other company, which is to make its products better, and the way to do that is to make them smarter. So if search can go beyond keywords and actually understand the meaning of language.
So especially for Dr. Kurzweil, the area you're in charge of, what is your target in your area?
Well, we're, as I said, trying to understand human language. It's hard to describe actually what that means. If you're doing a language translation, you can tell if it does a correct translation, and you can compare it to how well humans translate. You can tell if search is finding the information that people really want. But what does it mean to understand something? How do you represent the meaning of documents? So we have ideas about doing that. But the long-term goal is to enhance Google products, do a better job of search, read documents not just for their words and keywords, but actually understand what they mean, engage the user in a dialogue. That's the long-term goal of this research.
なるほど。
Especially in artificial intelligence, well, and then after singularity, but towards the singularity, we have time, about 30 years time. But for next 30 years, for us, human beings, what do we need to think and what kind of effort do we need to put in? If you could show us some directions, that would be much appreciated.
Well, one thing to understand with regard to artificial intelligence, while it might not do something as well as humans, it can do it at a much larger scale. So consider the IBM Watson system that played Jeopardy. Jeopardy is a game where you get an answer and you have to try to find the question that went with it. And it played the best two human players. And so it was asked, it was given this query: a long, tiresome speech delivered by a frothy pie topping. And Watson correctly responded, "What is a meringue harangue?" It's actually a pretty clever response. The humans didn't get that. And Watson got a higher score than the best two humans combined. And what's not widely appreciated is that Watson was not programmed with all this information by the engineers. It actually just read Wikipedia and several other encyclopedias, 200 million pages of natural language documents. Now, it doesn't read them as well as you do. It might read a document and conclude, Barack Obama, there's a 56% chance that Barack Obama is president of the United States. Now, you could read that document, and if you didn't happen to know that, conclude there's a 98% chance. So you can read that document better than Watson. So why is it that Watson could defeat the best players at this human language and knowledge game? Well, it makes up for its weak reading by reading more documents. It read 200 million documents. We can't do that. Probably read 100,000 documents pertaining to whether or not Obama is president. And it can combine all of these different probabilities using what's called Bayesian reasoning. So to overall, it can conclude there's 99.9% chance that Obama is president. So that's the current state of the art. And the ability to read each page is going to get gradually better and better. It'll be at human levels by 2029. And then computers can read at fantastic scale. But again, it's going to be something that expands our own intelligence. It does already. Even though they're not inside our brains yet, we carry them very close. These are brain extenders. As you mentioned, how many people could do their work without the brain extenders we have today? You know, whether you're a student or a professor or human relations executive, we all rely on these extensions of our intelligence. And these tools are going to get smarter and smarter.